Welcome to another episode of Nathan Builds Robots. Today we're going to be checking out the QidiTech X-Smart 3. This is QidiTech's answer to the Bambu Lab P1P. It's slightly cheaper, slightly smaller, and just as fast, if not faster. So let's open it up and check out how this thing performs. There's a spot for every little tool in here, but let's get to the real meat and potatoes of this video, which is going to be the actual 3D printer. And let's just pull it right out of the box here. And at the bottom there's just a little piece of styrofoam. Here's the whole printer. It comes wrapped in a plastic bag. Let's take that off. I'll just take off all of these little pieces of tape. More tape. Alright, and right here on the top it says, when printing with PLA or TPU, please remove the top cover. And I'm going to start out with some PLA, so I'll just set this aside. We can reinstall it later if we feel like printing some ABS. And we'll cut the zip ties, cut some more zip ties, remove a little cardboard from the print head. And here we go. You can see this thing has a tiny little build volume. It's quite a bit smaller than the P1P's build volume. It's about 3/4 the size. And if we take 18.5 squared versus 256 squared, you can see it's probably about half the actual print area. So it's a tinier printer, which should help it print faster in theory. It's got nice little guides at the back corners to help you install this just right. That was nice and easy to put into place. And you can see it's fully enclosed. If you have that lid on, you got these side walls here and this front door that can close. So you've got a nice enclosed 3D printer just straight out of the box. You don't have to mess around buying extra panels and cobbling stuff together to make it an enclosed printer. It just comes like this. So I like the styling that they've got here. I just took the protective film off of the screen. It looks like this thing's ready to go already. Seems like super minimal setup is required. If we take a look inside of the printer, you can see we've got carbon fiber rods here, top and bottom. And on the sides, it's got steel rods. So over here on the left and right sides, we're dealing with steel rods there. Seems very similar to the Bambu Lab printers. The cable management is handled really nicely up here. You can see at all four corners, it's just really nice, clean cable paths, and the Bowden tube is unlikely to have any issues here. Even when you jam it all the way into this corner, these cables are kind of tucked away inside of here, and everything seems to work really nicely. If we compare that to the Bambu Lab, we've got a little bit of cable and wiring sticking out the top, and I've looked on their website. I was interested in buying a cable guide like what comes on the Bambu Lab X1 Carbon, but they say not to install that here because it can damage the cable or something. So there's not a manufacturer supported way. So there's not a manufacturer supported way of having this cable nice and contained. I would really like to have that trapped in there and put a piece of glass over the top just like this. But it doesn't seem like that's an option supported by the manufacturer right now. So it's nice to see that this comes with everything you need to run it enclosed and just have all the cables neatly managed. If you look at the back of the machine, it's got a warning saying that the carbon fiber tubes cannot be replaced and to take care to avoid scratching them. That's a message that isn't included on the Bambu Lab P1P. But I think if you were to scratch those carbon rods, it would need to go back to the factory. So despite the lack of serviceability of those carbon fiber rods, it's nice that QidiTech is at least straightforward about it and tells you not to scratch them, and also just is informing you that they can't be replaced. With Bambu Lab, it took a little bit of back and forth with the support before they told me that, but QidiTech seems to be relatively upfront and honest about that. If we look here and here, there's some screws that I need to remove, which will unlock this print bed from the bottom of the machine. So I'm just going to go ahead and remove those screws. So since those screws have been removed, I'm just going to take these stickers out because they're a bit of an eyesore and just get everything looking nice. And I think we're ready to fire this thing up. QidiTech provides a special build plate leveling paper, which is nice to see. And let's see what else we've got. Here's our quick start guide. So let's see, all you gotta do is switch it to the correct voltage, plug the machine in, power it up, and you're good to go. So I'm gonna get ready to turn this machine on. I'm just going to install the spool holder back here, which is nice and easy to install. On the Bambu Lab machine, installing the spool holder took me about 5 minutes. I don't know if I'm just incredibly slow, but this is a nice and easy improvement that I think any 3D printer manufacturer could use. Just have something that's super easy to install like this, because all it's doing is holding a spool there. It doesn't need to be overcomplicated or overbuilt. I'm going to use QidiTech's own filament that they provided with this machine. So let's take this out. We'll cut the end of this off just because it's a little bent, and then feed it into this, which I assume is a filament runout detection sensor, and that feeds it right up into the top of the machine, through this Bowden tube, and right to the extruder. The switch to adjust the voltage is actually kind of tucked away down here, so this is going to take a minute for me to get access to. It's a slightly unfortunate location for that. I'm just going to verify that that's set to the correct voltage, because we don't need to fry this printer. We got to get through a whole review here, so just going to make sure it is able to start up and run correctly. Now these screws thread straight into plastic, so this isn't something that's designed to be taken apart and put back together 100 times. This is like something that you're going to want to take apart minimally. Now this is kind of annoying that I've got to take this whole thing apart, but for me it's not that big of a deal because I'm reviewing this printer and I'd like to see what kind of control board they've got down here anyways. So I'm just going to take this apart to take a look at that. But if you're not a reviewer like me and you were hoping that you would never have to take this thing apart, well, that's a little unfortunate for you, because you basically have to take this apart to check the voltage as it says to do. It's a 350 watt power supply like we've seen on so many 3D printers in the past. Over half the 3D printers that have come out in the last, I don't know, 5 years come with a 350 watt power supply. So this is pretty common stuff to see. And you really got to get in there deep like to inspect the voltage setting for this thing. Even from this angle I can't see it, so I've got to tip it up and take a look in there. Yeah, it says we're set to 115 volts, so we're all good. Just to have that peace of mind, you're going to have to take this whole bottom of the machine off, which is kind of annoying. It'd be nice if they had access to view it from the sides of the machine or the back of the machine, but that's all right. Now if we take a look at this control board, it looks like nothing I've really seen before. We got 3 stepper motors down here. I mean, I assume there's got to be 4 stepper motors for this whole machine to work. There's a MKS EMMC. This heatsink looks like it's on a little bit crooked. No idea what's going on with that. But yeah, we'll just get a good look at all of this stuff and see what's going on there. This must be some kind of special board that can run Clipper and power those stepper motors, because I don't see any auxiliary PCBs. This is all you've got. So this is all the brains and all the control circuit all built into one. Looks like we've got some RAM there, or some kind of memory, little computer thing, some capacitors, probably another processor underneath this large heatsink. I'm not sure what this is. Maybe it's some kind of wireless antenna. And we've got an Ethernet plug. Now note this Ethernet port doesn't really have anything plugged into it right now, so if you wanted to set that up, you might have to kind of bend this a little bit to get a Cat5 cable plugged in there. We've got a little USB-C plug. This looks like it might be some kind of power. It's got 4 pins on that plug, but it's not being used at the moment. And let's see what else we've got. Little terminal blocks. There's a lot going on here. This seems to be a pretty nice design. They definitely put some work into this. It's got a bunch of extra plugs for expandability options. Here's our terminals. They look really nice. We've got spade connectors on here, so really well done on the electronics. It's very professional in here. I'm just going to check these to make sure they're tight. Yep, those are tight. All of those are tight. Everything looks good here. We've got 2 extra USB-C ports, an SD card reader. I mean, this thing's just loaded to the brim with expandability options. So I'm guessing that QidiTech has invested in this board, and it's really going to be what they use for a lot of printers from here on out, just because there's so many expandability options that it's not taking full advantage of. So, you know, when they release their next printers, they have everything they need to build this out into another printer configuration. So pretty cool stuff there. If we look at this belt loop that we've got, there's one stepper motor here, and that powers 2 lead screws, one here and one here. And there's a little tensioning mechanism here. This doesn't seem super tight. I wonder if there's some way I can tighten that up. Just because I'm in here, I might as well. So to tighten that, I'm just going to loosen this screw here. Just going to push that to introduce some tension, and then retighten the screw. That seems like a good level of tension to me. So I'll just go ahead and put everything back together here. Turns out the power setting was just fine, but I like to check everything and make sure, especially if you're in a 240 volt country, if that's set to the wrong setting, that can blow out your 3D printer and you're not going to have a good time. Okay, so let's just put all this back together now. Oh wow, there's a couple more things here. It looks like there's some additional USB-A plugs here. Right here you can see this one is just routed to the side, so you can plug in your USB port and send files to this over, I guess, this USB cable that plugs directly into the main board. Right under that there's another USB-A plug, and then this appears to be some kind of, maybe it's a Wi-Fi chip or something. It says Tenda. This is a Tenda version 5 model W311MI. Not sure what this is, but we're just going to leave it plugged in. It's neat to see the use of so many USB components on here, because moving towards a standardized connector type, whether that's USB or JST or whatever, having a standardized connector type is going to make things a whole lot easier in terms of plugging in replacement parts. Like, let's say this cable goes bad, it's really easy to replace this because it's just a USB cable. Just like whatever this module is, you can just pop that out and plug a new one back in. Very nice to see this standardization around USB. So anyways, let's just put this bottom panel back on. This is not one of the funnest parts of owning a 3D printer, but I'm tempted to just leave this off. But I really should put it back on. Let's just get it done right. There's not a whole lot down here that I want to be messing around with, so let's just put the panel back in place. Anyways, this whole machine appears to be made out of a majority injection molded plastic. Very low cost of production. You're just paying for the plastic and slamming these out using their plastic injection mold. Alright, that's all put back together now. Now I'm confident that the power setting is correct. Let me just put that spool holder back on and plug this thing back in. Alright, and let's turn this puppy on and see what happens. It's not the quietest machine around. If you compare that to what we have with the P1P, the P1P makes almost no noise when you turn it on. This QidiTech, on the other hand, it kind of has some whirring fan noises. And I have a feeling most of that is coming from that power supply fan and the mainboard fan in the bottom of the machine. And yep, both of those are making some noise, so it could really benefit from using some silent fans, I think. That's an upgrade that we can put on here later, but it's worth noting for now that it just makes a little bit of noise at standby. So if we take a look at this, we want to change our language to English, unless you want to practice your Chinese or German today. Remove the zip ties. Yep, already done. Remove the 4 screws underneath the machine. We did that as well. About to moving platform. Please make sure the platform is clean and unlocked. Yep, okay. Let's see what we get. Go, printer, go. Alright, and look at that. It's moving nice and quickly there. That little knocking noise that you heard was the print head starting to move. Okay. For some reason the print head was kind of moving into the corner there. Maybe there's some kind of sensorless homing or something that is going on. Not entirely sure what's going on here. So it says remove the 4 screws that fixed hotbed. Okay. So there's just these 2 little plastic blocks underneath the heated bed. So we'll take those out and hit next. Wait for the initialization of platform and nozzle. Alright, let's wait for it. I was just saying how nice the spool holder is and I accidentally knocked it off. So that's a little annoying. You could print something out to help lock it into place, which maybe I'll do that in a minute here. But first I want to get started with the printing. Now, handling the filament all the way at the back of the machine is a little bit annoying. It seems like all the manufacturers are doing that now because filament is ugly looking and they want to hide it from you. But I would rather have something that's a little more accessible just to make things easier on me. That's just a personal preference. Having a spool holder on the side, like what you have on the Ender 5S1 over here, makes a whole lot more sense in my opinion, but it seems like everybody's moving to this back of the printer design. Now here's our special build plate leveling paper. We'll just make our little adjustments here until we can fit the build sheet underneath it. Okay, so that's just starting to pinch onto this piece of paper. I want it to be a little bit looser, so there we go. There's a little resistance between them. That seems about right. And hit next, input shaper. So we're going right ahead to doing the input shaper, so I'm going to move the printer up a little bit. And now you can see inside. Let's see how this input shaper does. And you can hear it making its little input shaper grumbling noise. Now there's a lot of plastic panels in here that might rattle a little bit. I doubt they're going to be rattling this much when it's actually printing, but during the input shaper you can definitely hear it making a little bit of extra noise. But that's true of virtually any machine that runs input shaper. Wow, and I could see the resonance of the belts. They were kind of wobbling around. Very cool. Holy cow, there's a input shaper resonance. These belts are just like tweaking out a little bit. So I assume it just did the x-axis and now it's doing the y-axis. So I'm going to try and get you an angle on these belts so you can see what I mean when they're wobbling around. Oh yeah, you can see that belt. That belt's wobbling. So as the frequency changes, due to the different lengths and tensions of these belts, different belts will start to resonate. So you can just kind of look around at all the belts of this machine while it's doing this calibration, and you can get an idea of why it's important to do input shaping. Just because all of these components, especially the more springy components like these belts, they're not very stiff. You can get resonances that can be pretty large. And you've also got other components that can resonate as well, like the metal bars here and these carbon fiber rods even, and all the plastic components. Those all have their own resonant frequencies that could be activated by these rapid motions. Now it's all done. Okay, so input shaper's done, and it's going to save those settings. Alright, keep pushing filament into the filament runout sensor until reach extruder. Okay, I can do that. It's a little annoying since it's on the back side of the machine, but let's do it. Okay, so we pushed it until it's reached the sensor. We've pushed it all the way in there and then hit next. check left side button to start heating nozzle temp. Okay. There we go. Oh, we're going to keep pushing this filament in. Oh. And if you push that filament too hard, then it kind of pops out the Bowden tube back here. So let's just reseat that Bowden tube. Yeah, that's not the best Bowden fitting in the world, but it's not like super important. Click below button for loading until filament come out from nozzle. Okay, it looks like some filament already came out of the nozzle, but that's red filament and I've got black filament here, so that might have just happened to come out from the factory test that they probably did on this machine. Okay, you're just going to want to keep pressing this button. Just keep pressing this button until you get some filament coming out the end. Keep pressing button. Keep pressing button. Alright, there we go. Now our filament's coming out. Sweet. I'm just going to keep extruding until we get our black filament coming out the end. And this seems to melt the filament quite nicely there. We're going to hit next. Guided tutorial finished. Alright, now that our guided tutorial is finished, I guess we're ready to start printing. So, here goes nothing. I'm just going to go ahead and print any kind of files that are already on here. I can turn the lights on and off. Let's see. I just pressed the light button and the lights are still on, so we'll give it a minute. It's homing the device. Moving to the front corner. Looks like it's using sensorless homing too, so that's pretty cool. We can turn the lights on and off. We can turn the beeps on and off. Let's see what else we got. No USB drive detected. We got some manual controls here and languages. So let's plug in a USB drive. I think one came with the machine. And they're not cheaping out on the USB drive either. Take a look at that. They give you a 16 gigabyte USB drive. So I'm just going to plug that in down on the side here. Any USB drive detected yet? Maybe I gotta go to the other screen and go back. Yeah, there we go. Let's see. Slicer software? Nah. CFFFP G-code. Alright, we'll give that one a try. I can't see what exactly it does, but let's just print it, see what happens. Maybe it's a speed benchy. 40 minutes is a decent amount of time for a speed benchy. That's how fast I was printing with my P1P and my Ender 5S1 that's on a Sonic pad, and I was getting pretty decent results from it. So now it's time to see what the QidiTech can do at that same speed. Now you'll notice there's a little feature at the front here. At the very front of this build surface, I don't know how well that's going to show up on camera, but you can see there's a little, it's like a little cutout. I don't know if that's for cleaning or maybe that's for their manufacturing processes, but I imagine the nozzle can wipe on this little piece, and it's somewhat spring-loaded, and I just pushed on it while it's trying to print, so I might have messed with the print job. It's kind of hard to notice that it actually started printing though because of how quiet it is. At least the motors are very quiet on this machine. Now these fans in the base of the machine could definitely use some work. There's no reason they should be this loud. I'd definitely like to see that fixed using some quiet fan mods. But other than that, this machine appears to be doing a nice job and running nice and quiet. It's going pretty slow for this first layer, but that's typically what you want to do, and on the higher layers you can really speed things up. Now I noticed I didn't have to level all four corners of the bed. It just had me level the middle, and it looks like we've got solid posts down there. If you take a look under here, we've got some metal looking posts. No springs to be found down here, so you're not going to have to adjust those yourself. They're just going to come pre-adjusted from the factory. I'm not sure what kind of bed leveling system they've got going on here, but it seems to be confident enough to just get started. I didn't really do any special bed leveling or calibrations here, and it's gone ahead and just started printing this This little cube or something that we've got here. Now it looks like the first layer isn't coming out perfect. If you're looking for tips on how to get the perfect first layer, you should head to perfectfirstlayer.com. But let's see, I'm going to move the print head. I want to move it further away from the bed here, so I'm not sure how to do that. Maybe I just fixed it. We'll see. I think I'm going the wrong way now. We'll see how this turns out. It's doing some weird math up here where it's like plus, minus, you're adding a negative number or something. That's a little bit too much math for me. So let's just let it print and see what we come up with here. I'd like to see it printing a little bit faster than this. So maybe we can turn the speed up here. I guess I'll turn the speed up on the next layer. We'll let it finish this one just because I'm not sure if this is like, maybe it goes slow for the first 2 layers or something. But just take a listen to all the fans on this machine. I think it's a little bit loud for what it is. Okay, so this is clearly way too slow for this machine. This machine is built to print fast, so I'm going to go in here. I think it can handle way more than what it's given itself credit for here. So I'm going to set it to 500%. I think that'll be a nice speed increase. So we'll hit 500, hit that check mark. Let's see if it goes any faster. There we go. What's the point of having input shaper and all these high quality components if you're not going to use them? And I think we can go even faster than that. Let's bump it up to 800%. There we go, 800%. That's more like it. Uh-oh, looks like we've got a little bit of under extrusion at 800% speed. So let's turn that back down to 500. Oh my goodness, it's going fast. Well, the motion system can certainly handle the speed. I'm not sure if the hot end is keeping up. I'm just going to forget about the concerns here with, I'm just going to turn this up to 260 degrees. We're just printing PLA right now. But I think we got to heat things up here. We'll turn that up to 260, and then we'll increase the speed to 1,000%. Won't let me go to 1,000, so I just got to go to 999. There we go. That's more like it. Alright, let's cancel this print. Yeah, let's stop it. Okay, so clearly we got a little bit of, oh my goodness, that was scary. You definitely don't want to put your hands in there while this thing is operating because it's fast. So it looks like we had a little bit of under extrusion. I think I could counter that by turning the hot end temperature way up. And we're just going to give that another try. Unfortunately, our first layer was not perfect. It was being pressed into the heated bed a little bit too much. If you take a look at this, it's like kind of wobbly and weird. So yeah, it's definitely too close to the heated bed. Let's get that cleaned up. There was a little bit of oil in the printer when I unboxed it, so if we get some alcohol wipes or something, maybe we'll get slightly better adhesion results. I always use these little lens cleaning wipes to clean up my printer's heated beds, just because they've got a little alcohol in there, and they're nice and clean and sterile, and they got a little scrubby action, so they do a pretty good job of cleaning up the heated bed. That'll definitely make sure you remove any little bits of oil on here that could mess with your bed adhesion. Alright, and let's try that print again. I'm not sure what the Z offset should be. That's one of the annoying things about setting up a printer like this. The P1P offers a little bit of an easier experience because it sets up your first layer for you. With this machine and basically anything that uses a little probe like that, you need to get in there and adjust it by hand. It's a manual process, and your success will depend on your level of skill and your level of luck. So it's not ideal, to say the least, and I wish it was just fully automatic like what you have on the P1P. And the Ming the Magician X was one of the first to do it. And there was a printer by Creality that did the same thing as well. We'll see how this first layer turns out. It's looking pretty nice. I think I might just leave it on that setting. However, we are going a little slow, so I'd like to turn this up. Maybe we'll go to 300% or 333. Oh, this is a lovely noise. I don't know why it's making this noise. I think that's just the rattling between the carbon fiber rod and the print head. Lovely noise they've got going there. Alright, I think we can bump the speed up again. Let's go to 667 because we don't use that number. Oh yeah, and then I'm going to have to turn the extruder temperature up. Let's go to 280. I don't want any under extrusion-ish. Oh no, we've come loose again. It looks like we had really good contact with the bed this time, so I'm not sure why it came loose. It feels like the bed didn't heat up at all. Why are we using a cold plate here? That's ridiculous. What kind of G-code are you loading on this machine, QidiTech? You gotta load some good G-code on here. Not this crap that doesn't even bother heating up the bed. That's not good at all. Okay, well, since that model that they're providing is completely useless, I'm just going to go ahead and slice my own stuff and send it over to here. So to get this thing plugged into... Alright, and we're connected. And our IP address is 192.168.1.231. So I'm just going to type that in on my computer, and I should be able to load up access to this printer. Alright, so I tried typing that IP address in on my MacBook and it wouldn't connect. We'll try it on my, my Windows laptop. This also can't connect. Very strange, isn't it? Did I type that in wrong? 192.168.1.231. Yeah, that's not good, QidiTech. What's going on here? I feel cheated. Now, let's check out the automatic bed leveling procedure here. It says to make sure there's no filament on the tip. Alright. And I guess it's going to do its thing. Now, while that's getting sorted out, I'm going to slice another model here. Alright, so now I'm just going to slice my files and upload them the old-fashioned way. I've got my USB drive plugged into the computer here. This is slightly bigger than the Voron Zero. But you know what, it'll do. Let's just try out some of these Voron Zero profiles. And what I'm going to do here is go to printer settings. Let's change our bed shape to 185 by, we'll go to our platter, our delicious platter here, and we'll drop some files in there. Let's do a benchy, and then after that we'll do one of these calibration prints. So benchy first, let's slice it. 1 hour and 24 minutes. Nah, we can do faster than that. Oh, these are some garbage print profiles. Maybe I need to install the new configuration assistant. Alright, so the configuration assistant has been updated. Let's try the Voron V2. There's really not a whole lot of settings here. We're doing this the old-fashioned way just because I couldn't get the things running there. But right now it's telling me to do some bed leveling stuff, so let's go ahead and do that. Use the up-down buttons to calibrate the thingy. I mean, this touchscreen isn't super responsive, which is making this more annoying than it needs to be. Alright, this seems just about right. And when you're trying to figure out which direction to move things, just remember down is telling you the direction that the bed moves in. A lot of times it can get kind of confusing because everything's relative, but you're going to want to move it in the direction that the bed is moving. So if you want the bed to move up, you press up. If you want the bed to move down, you press down. And that's a little bit confusing because basically when you press down, it's making the Z coordinate go up. So nice and confusing there. That's one of the reasons why I prefer the P1P's bed leveling system, where it just does everything for you. Because I don't like having to be smart to be able to use my printer. And right now it's doing the bed leveling, the automatic bed leveling. If you take a look under here, there's like a little blue probe towards the back of the machine, and that there is your inductive probe. It's really hard to see because of how dark it is in there, but I think you might be able to see it if you look hard enough. Yeah, there it is. And because you're using an inductive probe instead of the actual nozzle itself touching the bed, you're going to have to program in that offset yourself. So they call it the QidiTech X Smart 3, but really you're the one that has to be smart to get it to work. So here's our little bed mesh. I don't know why all the numbers are offset by 2.3 millimeters from 0, but alright. We'll go with it. Yeah, it just can't connect to that IP address, so there's not a whole lot we can do there. Really unfortunate that the networking isn't working right out of the box. That seems like something that they could test at the factory, just to make sure you don't have any fiascos like this. Now you've got the most important reviewer in the world, which is me, of course. I'm being slightly inconvenienced. How dare they? There we go, 100 millimeter benchy. Now the internal perimeters are going at 100 millimeters per second. I don't have my preview here because I'm not using the QidiTech slicer, which I guess I'll try that a little bit later. 84-minute benchy, so I'm not sure why it's saying it's a 40-minute benchy here. Kind of an odd thing to say, don't you think? Maybe it just says everything takes 40 minutes. Now, while that's messing around, I'm going to install the QidiTech slicer that's included on the SD card onto this burner laptop. I don't do anything important on this laptop, it just runs all these sketchy Chinese software that the 3D printer companies send me. So let's get that started. Oh my goodness! Oh my. Jeez. Okay. Anyways, Qidi setup 6.5. Let's go. Now this was last updated on March 30th, so this should be a pretty recently made file. Hopefully everything works. Yes, we'll go ahead and run it. English. Next, I agree. Install. So maybe using this software I'll be able to communicate with the printer here. Alright, let's open up QidiPrint and see what we got. Oh no. It says there's missing a DLL, so I can't run the Qidi software. That's kind of unfortunate now, isn't it? Yeah. Oh well. Alright, I got it. Okay. Let's just move on. Okay, so the Qidi software isn't working on my laptop, but that's alright. Let's go ahead and just... We're going to run the files that I sliced in Prusa Slicer using the Voron slicer settings. So, alright, that's fine. Let's go. Takes a minute for the USB drive to get detected. Hello? Alright, so it's no longer detecting the USB device. That's not good. Alright, I'm going to go ahead and restart the machine, see if that fixes anything. Alright, QidiTech, let's go. This thing only takes a few short minutes to boot up. Yeah, this is kind of long. Good old QidiTech. Let's boot up. What? The system starts abnormally. Please turn off the machine and wait a while before restarting. Uh-oh. You really got to give this thing a big hug when you're trying to turn it on and off. The power button's way back there. Oh, wait. It says to turn it off for a while. Let's just, we'll give it a minute. Alright, so we gave it a minute. We're going to turn it back on. Alright, QidiTech, I believe in you. Let's boot up. It's time to boot up. Alright, it booted up right this time, so I guess that's a good thing. Let's go over here, and let's print our 100mm bench sheet. Oh gosh! Oh no! Come on, Qidi, why are you doing this? What are you doing? Oh no! Jeez! Holy cow! Ah! Okay. Oh my gosh. I guess it didn't home itself first or something. This is the first 3D printer that I've ever used where you have to manually home it before you get started here. But let's go ahead and home the machine. Holy cow. So I'm guessing that it needs to be homed in the starting G-code. Otherwise it's just going to go all crazy on itself. So that'll, I think everything's fine. We're just going to continue on with the review here. Don't worry, everything's fine. Let's start up that 3D benchy. Alright, so it just had to home before it got started. I guess we're all good now, so I'll just leave it there. I like how wide this door opens. It opens all the way up like that. So it gets nice and out of the way. And we're ready to start printing. This is all great. Just forget about that little thing that happened earlier. We're not going to worry about that. So this benchy is going to complete in, well, it's not showing up here. I guess it's using some other type of G-code system with the Qidi slicer, that the information wasn't saved to the SD card properly using prusa slicer. But we're going to go ahead and turn the speed up. I think we can handle 400 millimeters per second. So we're just going to go to 400 here. And we'll see how fast we can go. Now our heated bed is actually up to temperature, so hopefully this thing will stick a little bit better. I know this thing can handle some more extreme speeds and accelerations, but let's just go ahead and let this run and see what kind of results we can get. Oh, it looks like the screen actually displays a live estimate based on how fast it's printing. So now it's predicting there's like 34 or 35 minutes left on this print. And that's just based on the number of lines of G-code or something. I'm not sure how they're calculating that. But it looks like this will turn out to be about a 40-minute benchy. Right now I'm about an arm's length away from the 3D printer, and I'm going to get a sound level reading on my phone. So we're going to see what kind of decibels we're putting out right now. Alright, so it looks like we're about 53 decibels when the print head is moving pretty slow, and during those rapid moves it's peaking up to about 58 decibels. So not the quietest machine in the world, but not the loudest either. Alright, and our print is done, so let's take a look. That actually looks pretty fantastic if you ask me. So let's pull that off. Ooh, that's some pretty good bed adhesion. Alright, so let's take a look at this benchy. That's some pretty good quality there. It's a good job by QidiTech, you know. Nice high quality benchy in 40 minutes. Very sharp details. Super nice quality. Just a tiny little bit of wisps here, and those will clean up nice and easy. So, good result, good overhangs, clean details all along the outside. That's what we call a good result. And that was finished in 46 minutes. So not the fastest benchy in the world. Then again, we could have sped it up a little bit and it would have been fine, probably. I guess I'll do one more benchy, but I'll actually turn it up to insane levels. Actually, I'm going to cancel that, and I'm going to make sure that I've homed the machine first, because there's some kind of startup G-code that this printer needs to run in order to prevent itself from crashing into stuff, and my prusa slicer isn't providing that G-code, so I've got to just figure that out for it. Not the end of the world, but then again we're going to have to wait for it to heat all the way up before it lets me change any of these settings. So it looks like when you cancel... Oh my goodness! It keeps doing this. Okay, so this machine needs to home itself more often. It needs to figure out where it is relative to everything else. So just go ahead and home it between everything that you do with it. And if you're writing your own custom G-code, make sure to have it home itself at the beginning and end of every print, because you don't want it to be all smashing into stuff like this all the time. It'll basically be testing out a bunch of the different aspects of this machine, so we'll see how it prints this thing out. Now, this test print I do on a lot of other printers. Here's the one that I printed using the Soval SV06. It's not quite as good. You can see it's got some layer shifts there. Overall, the quality is really nice. It's just, you know, that layer shift is kind of a major issue. And also, when you get to 70 degrees of overhang, it starts having some issues there. But overall, print quality was very high for this SV06 that I was testing. Just, you know, it failed a couple spots there. So, we'll see how the QidiTech does. We're going to run this exact same print and see what kind of overhang and stringing and retraction tests and bridging tests. We'll see how all that turns out here. And I'm just going to let it run at the normal speed that I sliced it. It'll be printing at 100 millimeters per second on average. So we'll see how it performs. Oh yeah, that's nice. And just to switch things up a little bit, let's get another angle so that you don't have to look at it from the same point of view every time. So I'm actually going to bump up the speeds and we'll print this slightly fast. We're going to go to 200% speed. So this means on most of the perimeters it's going to be printing at 200 millimeters per second. This is pretty cool. There's some red LEDs in the back of the print head. So there's obviously some kind of little breakout board in there. It's a pretty cool little design. So there's this buzzing noise that's actually pretty bad. And I think that's coming from the interference fit between this carbon fiber rod and the brass bushings or whatever they have on the inside here. Alright, and I just set up the microphone so that it's right at the tip of the camera, so you'll just be listening to the printer from here on out. And actually, I'm going to turn this up to 400% speed. Oh no. Oh no. When it prints this fast, it definitely has to heat that nozzle up a little bit more. So I just turned the temperature up to 260, and you can see it's helped alleviate a lot of that under extrusion issues that we were having. So hopefully it can recover from this by just putting some nice plastic down on top of that nasty stuff we just laid down. Alright, I'm going to turn things down a little bit. So I'm going to set the temperature back down to 225 degrees. And I'm going to set the speed back down to 200. So now the maximum print speeds we should see will be 250 millimeters per second on the infill. So it'll just go a little bit slower now. But, you know, this isn't all that much slower. It's still quite fast. This printer sounds absolutely awesome when it's running. It just sounds really badass. So we're just going to let this thing print, go in this speed. We'll see what kind of quality we get in the end, but I mean, as you can see, it's moving pretty fast. Alright, so here we have it. This is the printed part. It's looking pretty nice. Really good overhangs all the way up to 70 degrees with virtually no artifacts. And this was printed at a pretty high speed. So quite impressed there. We see the first signs of any kind of issue at 75 degrees. And then at 80 degrees we're seeing a little bit of artifacting. I probably wouldn't want to print this fast with this much overhang. In terms of stringing, there's virtually none. bridging tests turned out pretty good. The detail and the text is all readable. Not perfect, but it's readable. If we look at the text on the front here, that's looking pretty good. You can see some slight ringing though, so not all the ringing was taken out of the system with that vibration compensation. But altogether, an extremely impressive result, especially at the speed that this was printing at. So I think we've got a fantastic piece of hardware here with the X Smart 3. However, one little issue that I have is if we look at the belts, they seem a little bit loose. This is just one reviewer's opinion that these belts seem a little loose. I mean, just take a look. They're just kind of, they're okay. You can strum them a little bit. But they just seem kind of loose to me, so I'm going to try and tighten that up. So I've been removing some of the screws on the back panel here. I'll take off this spool holder. I took all these 4 screws out, and it looks like we pop this lid piece upwards, so I'm just kind of prying it off just like this. But everything on here fits together really tightly, so this is somewhat difficult to do. But it can be done. If you've ever taken apart like a computer monitor, one of those LCD monitors, they are kind of put together the same way with these plastic clips. Just kind of pop everything off the top here. All right. And then we've exposed this sheet metal frame. You can see all around here, this is a nice little bit of sheet metal work. And hopefully this will allow us to remove this back panel. So I've taken out several screws. It looks like this piece here is kind of hooked up to it. But we can get a pretty decent view of everything that's going on here from up above. It looks like they've added plenty of stiffening features. So you add kind of like this beaded thing into these sheet metal components. And that'll stiffen things up a little bit, because if it's just flat there, it's easy for it to fold and vibrate. So you just kind of press a bead into it and that stiffens it up. Nice, cheap, / free way to add some better mechanical properties into your sheet metal parts. But the big question to me right now is, how do I tension these belts? Because I want to tighten them up a little bit. They just seem a little loose to me. And I'm trying to figure out how I can do that. Now it seems like these belts have been clamped into this plastic piece. In between this part and this part, there's kind of some belt nubs sticking out here. So I think that's probably how I'm going to have to adjust this tension. There might be some other way to do it, but just looking around, I'm not seeing anything that's obvious. These belts seem rather loose to me. I didn't get any instructions on how to adjust the tension here. I'm just assuming I'll have to do it by loosening this stuff up and just kind of reclamping it. So let's give that a try. It looks like there's a little removable panel here that'll let us take a look at the electronics, and we've got a little breakout board there. It's always nice to see little breakout boards just to make the electronics work a little bit easier. I've got a nice little light here, so I'll toss that in position so you can kind of see what's going on there. Let's give it a little zoom action. Zoom, zoom. Okay, so you can see the little breakout board right there. It's looking pretty nice. I'm going to go ahead and take these 4 screws out to remove this white piece, and hopefully that'll give me a better look at what's going on in there. Now, one thing to note about this machine is they make extensive use of these little plastic threaded screws. There's nothing wrong with that. It holds the machine together just fine. However, if you're doing a lot of assembly and disassembly, eventually these screws might start to wear out and the machine might not go together again after maybe 20 or 30 assembly and disassembly cycles. Now, I don't expect most people to have to take this apart all that often, and if you are taking this apart, you're probably just going to fix it and put it back together, or you're going to replace this whole hot end with something else. However, I'm just noting that this isn't like an infinitely serviceable machine just because of these screws and the choice of carbon fiber rods. So let's take a nice look at things in here. And this is what we've got under the hood. This is a pretty nice little hot end here. It's just a little breakout board. It looks like we've got one cable, which is just a USB cable, coming into here. Looks like this cable is being pinched slightly, but that's just the plastic housing kind of pinching onto it. I don't think that's likely to cause an issue in the long term because these USB cables are pretty thick and they have some metallic shielding usually, so it's unlikely for that to wear through in any short amount of time. Then we've got our hot end over here. No, this is our inductive probe over here, and that plugs in just right there, kind of in a funny way. We've got it split up into two little connectors. We've also got all of our fan plugs, our stepper motor plug, and a hot end kind of heater plug there. So this is a really sweet hot end design. It's got its own little microprocessor. Oh, it looks like a little Raspberry Pi symbol on there, so this must be like one of those Raspberry Pi mini things. But in any case, we can see right here, these are our little belt nubbins that are sticking out the side. So I'm thinking if I loosen up, let me just unplug this USB-C. If I loosen up these little clamps, I think I can pull on those belts and set them to be a little bit higher tension. So I'm going to give that a try right now. Alright, so this top belt is rather loose. I mean, just listen to it. Kind of loose sounding, so I'm going to go ahead and loosen up these bolts. So that's nice and loose now. And I'm going to grab it with some of my pliers and just pull it tight and then retension that little clamp. So here goes. Got my little Nipex pliers. We'll grab that and pull. Oops. Alright, that's not working too well, so I think I'm going to have to completely remove this little tab so that I can have better access to that little belt nubbin there. And again, these are more plastic screws. There's no metal inserts on the other side here. We're just threading this directly into the plastic casing of this sled. So we'll see how that works, and hopefully that holds up long term. So now I'm going to grab this belt and just give it a nice little pull to set a higher amount of tension. Alright, and that's pretty good. The only issue is now I need an extra set of hands here because this is quite difficult to do all of this with a mere 2 hands. Shoot, so I think I'm going to have to hold this. It would be nice if gravity was working with me here, but the way that I've got this situated so that I can film it, it's kind of tipped up and back, so we are not doing this on easy mode. And I don't want to drop this screw because it will fall into the abyss if I let go. So, holy cow, this is difficult. Ah, no! Okay. Well, I gotta fish that out, and I'm gonna reposition this to make it a little bit easier to work on. So I think what we're gonna do here is I'm gonna flip this around. Now gravity's on our side, so our old friend gravity is here to help. So let's give this another try. We just gotta grab this. Oh, jeez. Now I'm not even sure if this is the right way to be doing this operation, but in the absence of anyone telling me what to do, I'm just gonna go for it. Alright, so I'm gonna just try and retighten this now. Drop one of our little screws in there. Okay, there we go. We got it started. Oh wow, I actually broke a little piece off. I broke off this little bit right here that was holding onto this little foam block that helps secure the USB-C cable. Hopefully it's not that important though. Well, let's keep going for this repair job. So we've got one screw in, now we'll put the other in. And there we go. I'm not going to let go of this belt until this is all tightened down, because I do not want to mess this up. No, okay. We'll tighten that down, and you don't want to strip those screws either. All right, so now this belt is a heck of a lot tighter. It might even be too tight, but we'll see. I don't really know how these corexy systems go or how tight the belts need to be. I just have a tendency to over-tighten them, if anything, just because if it's loose, that's going to cause kind of some low-frequency ringing, versus if it's too tight, it might cause some higher frequency ringing, but I'm less worried about that. It also might increase wear, so yeah, there's some potential issues that might come up. So on this one, I just removed one of the screws, and now I'm going to see if I can just kind of pull this through. That might be a little bit easier than fully taking this thing apart. Not sure if it'll work though, but let's find out. It's not going so great. I'm going to loosen this screw up just a little bit. Oh. And now you can see that that belt is pulling itself out, so I guess I'm going to have to loosen that a little bit more. And maybe I don't have to take this screw all the way out. I can just back it up to the point where it's kind of out of the way. And then I can get in there with some pliers. Yeah, there we go. So I'll just pull this. Oof. I'll just pull this roughly to the same amount of tension that I had on the other belt. So it looks like I'm adding about 2 teeth here. And don't quote me on this. I have no idea if I'm using the right procedure at all to adjust belt tension. Maybe there's a belt tensioner somewhere else on this machine. But we're just going for it. Oh, jeez. Alright, so we'll see. Maybe I can just tighten one of these down and that'll hold it in place. And then I can use the pliers to grab that other screw I just dropped. There we go. Alright, and there we have it. So, shoot. These seem roughly to be the same tension. One of the belts is tighter than the other, so I'm going to adjust this and let one tooth out from this, this closer belt, just because I tightened it more than the other one and I just want to have them be a little bit more equal. So I'll grab it with the pliers just like this, loosen up this little thingy here, let one tooth go in and then retighten it. And these Allen keys that I'm using just suck, so bear with me. But you can see on this one it just spins freely, so that's not good. See, I'm just spinning this around in a circle. I guess I have to use the other end of the Allen key. But no, that just spins freely as well. So I have this other Allen key that seems like it's on the larger end of the tolerance range, and it's able to turn this screw. And this is one of the things that I don't really like about these 3D printers from China, that I have never really worked on anything else that has so many issues with low quality fasteners. This isn't just a QidiTech issue. Virtually all brands that I've done extensive assembly and disassembly on have these issues where they've got just low quality, out of spec fasteners. But we're just going to try and get this tightened in. And this is a big reason why you don't want to use this type of like plastic screw for these important components on the 3D printer. Because if those plastic screws strip out, then what do? Do you just throw the whole printer away or figure out how to put a heat set insert in there? I mean, sure, they're saving a little bit of money on the assembly costs. So that saves a little bit of money when you're assembling and manufacturing this thing. But, you know, this whole thing's just stripped out now and I can't really tighten it. So that's going to be really bad for long-term repairability. But if you just look at the tolerances on these things, I haven't checked this. This will be, you know, we're doing it live. We're seeing what kind of dimensioning we got here. So 0.145. And we'll measure this other random Allen key that I'm using. and this one's 0.148. So that's a pretty significant variance between one tool and another. 148 versus 145. It's like these things that are small especially need to be made very precisely. But you don't really see that in Chinese fasteners like this. That's just the way things go. And on top of that, this is threading into plastic. So as soon as that gets stripped out, do you know what you're going to do with this machine? I have a suspicion you might be throwing it in the trash. You know, you could make this a little bit more durable by at least having those fasteners be a little bit longer. Like these ones that they've got here. These ones are pretty long. Oops. Like these ones, they've got a longer section in terms of the threaded part. And these are just used to hold this plastic cover on. These ones that are important for holding the motion system together, you'd expect them to use a higher quality fastening system. So here's what I'm going to do. This one right here is kind of on its last legs. So I'm just going to try and extract it. We'll see if we can get it out. There we go. So hopefully this doesn't fly apart when I take this screw out. It's all good. So just compare these screws side by side and tell me which one you think should be used to hold the belts on this machine, which is, you know, under tension, and it's a very important part of the motion system. You've only got like a millimeter or two of teeth dug into plastic to hold that on. So I'm going to, instead of using this very minimal amount of plastic threading, I'm going to use this longer fastener to plug in right over here. Hopefully that hole goes down deep enough for this to work. This is probably a terrible idea. But you know, we're just going to go with it and see what happens. It's kind of hard to thread in, but that just means it's digging into more plastic. So we'll tighten that down, and that should be much sturdier than what was originally in there, which is these tiny little screws. I'm tempted to replace all 4 of those screws, but these 3 were actually kind of decently seated in there, so I'm not going to mess with them. So there you have it. Tiny little screws like that. We don't need them. Let's get everything put back together. Now our belt tension is a little bit tighter. And you know, they could have used these fasteners here. It'll cut down on the number of unique fasteners on this device because you're just using these ones that are also used to hold this back plate on. So reducing fastener count, always a good thing, or at least reducing the number of unique fasteners. So yeah, I feel good about that. Let's put these back in place. The easiest way to do this is probably to preload these screws into this housing. And of course I'm missing one now, so we're just going to screw 3 of these in. And again, there's nothing wrong with threading these fasteners directly into plastic, as long as you're not planning to take this apart and put it back together 100 times. Yeah, just don't take this apart all the time and you should be fine. I didn't get a chance to see what kind of bushing is being used in here. I'm guessing it's a brass bushing with graphite inserts, the same one that Bambu Lab is using, but I was not able to verify that. And essentially we just tightened this up by removing 1 tooth from this belt loop on both the top and bottom belts. And now when I strum these belts on the side, you can hear it. It's not super tight, but I think it's better than how it was stock. So hopefully this is an improvement. We'll run that same print again and see if that improves our print quality. And while we're at it, let's just flip this back upright. So if we take a look at the extruder here, it looks like we've got a pretty nice little setup. We've got large diameter drive gears for the filament, and it looks like all plastic gears. The gear coming off of the stepper motor looks like it's metal actually, so I'm not sure what's all going on inside of here, but there's some kind of real compact magical stuff going on in there to help make this a super small and lightweight tool head. And I'm just going to go ahead and put this back on. It goes on nice and easy. It's just held on with some plastic little clips, but it seems to work quite well. Alright, so I guess I didn't really need to take this top piece off. I'm just going to go ahead and smack it back on here. It's just held on with plastic clips as well, so That's one of the ways they were able to get the cost down. Just injection mold this whole thing so that it just snaps together. And there you go. There's a couple screws missing from the back, but I honestly don't think they were that important. I'm just going to run it like this. So let's plug her back in and run some test prints. So it's plugged in, we'll turn it on. It says booting up, please wait. Sometimes this takes a little while, so let's just stand by. Alright, you know the boot up was successful when those lights turn on. Every time the lights turn on, it basically boots up right after that. So that only takes about a minute. Let's go into the settings and we'll see if we can rerun that input shaper. So right there, it's right in the calibration menu. We'll just press input shaper and let it do its thing. So right at the start of the input shaper operation, it homes the whole machine, which is nice to see. They actually use sensorless homing for a lot of the stuff on this machine. Wow, that sensorless homing didn't work correctly because it was all the way at the back there and it bumped up against something. Yeah, they really got to work on the firmware just a little bit on this machine. It's not completely horrible, but it's not the best either. So now it's input shaping, but it's not in the middle. Hopefully that doesn't have too big of an effect on things. But yeah, this machine uses sensorless homing for the X and Y, and it looks like it uses a little sensor back there. You can see it kind of right back there for the Z-axis. So let's let this thing do its vibration compensation vibratey thing, and I'm going to run the same test over again and see if I get better print results. Alright, so now I'm homing this one more time so that I can start up this next line of G code. And really, I think this machine is expecting a homing operation in its start and end G code. So that's why it's going through this process where I basically have to manually home it before I fire up this G code because it's not really designed for this machine. This is G code that's designed for a Voron, which I assume runs its own homing procedure before you start a print. So we're going to go to our 100 millimeters per second calibration G code and we'll hit go. And I'm also going to turn the speed up to 200, which is the speed that this last calibration print ran at. So basically the idea here is to just print this again with the tighter belt tension and see if that improves the ringing performance here. So I noticed some ringing. It's not an unacceptable amount of ringing, but it's more than I'd like for a machine like this. So we'll give it a shot, see how it goes. Alright, so now we've got the next test started. It looks like the first layer is going down pretty nice, even though I just had this machine flipped over and I was working on it. Seems like it held zero quite well. So let's just go ahead and let this thing print and we'll see what we get out at the end. Now the fun thing about this printer is you can crank this way up, so I'm just going to test this out a little bit. We'll set the extruder to 260 degrees. And you can see, thanks to that ceramic style hot end, it heats up super fast. And now we're going to set the speed to something like 600% and see what happens. That should be printing at speeds of roughly, well, very fast speeds. It might be acceleration limited at this point, but let's see it go. This machine does a great job of laying that plastic down quickly and accurately, and it sounds awesome while it's doing it. This machine is just stupidly fast, and it's really fun to turn it up to those super high speeds. But for the sake of consistency and to make sure that I get a good result for these tests, I'm going to turn it back down to 200%, and we'll turn the temperature back down to 215, I think it was. Maybe it was 210. I think it was 215. But anyways, yeah, we'll turn that speed back down. We'll get our next print results. And hopefully they'll be a little bit better thanks to those tighter belts and thanks to that retuning of the input shaper. Right now those perimeters should be printing at about 200 millimeters per second, and this infill stuff should be printing at between 250 and 300 millimeters per second. So very fast printing at really good quality here. So that's definitely one of the strengths of this machine. Just excellent hardware that's able to print super fast. Alright, so we'll switch this one into time-lapse mode and then we'll analyze the results when it's done. Alright, time to sum up my thoughts on this QidiTech X Smart. The pros are that it's well built, has high print speeds, high print quality, and a very low price. It's about $150 cheaper than the Creality K1 and $250 cheaper than the Bambu Lab P1P. And in terms of features, the P1P, the K1, and this X Smart 3 are all pretty similar. They all feature high-speed print heads that are able to move very fast. And one thing that I really like about the modability of this machine is that they're using standard JST plugs. So if you wanted to plug in other random stuff onto this printer, it'd be much easier than what you have on the Bambu Lab P1P or even possibly the K1. However, there are some significant cons with this machine. The build quality seems a little bit lower than the competitors, that being the K1 and the P1P, and the entire enclosure is made out of kind of cheap feeling injection molded plastic. The Bambu Lab P1P and X1C are pretty much all metal construction, so they feel a lot more premium and solid, and the Creality K1 is all metal with some plastic panels, and it overall feels like a very high quality construction as well. So this machine kind of misses the mark in comparison to those other machines. However, it's a much cheaper printer, so that's where you're saving the price. I think this printer is capable of incredibly fast speeds though, so you're sacrificing a lot of things, but you're keeping that high print speed, which I think is really this machine's most outstanding feature. Also, you can interface with the machine using a pretty much stock Clipper interface. So I don't know if you call that a fluid or mainsail interface or whatever it is, but you can log into it and upload your files just like you would with a normal Clipper machine or the Creality Sonic Pad. So that's a pro in my opinion. I don't like having to go through the slicer and using cloud functions to be able to send parts over to my printers. Also, compared to the other printers that I mentioned, the K1 and the P1P, the induction probe requires a little bit more setup to get everything dialed in. This is very early days for this machine, and there's probably going to be some software and firmware updates that are going to get this machine all the way up to the level that it needs to be. So I wouldn't be too worried about some of the software issues that I was having in this video. That'll probably all get cleared up in a couple of months. But it's clear to me that their priority was building an amazing printer and putting it together at basically the lowest price possible. And it comes with some great electrical and mechanical hardware. So just be aware, if you want to be an early adopter to this machine, there might be some little gaps in the software and firmware experience. And if you're looking at this review at a much later date than May 2023, then you might want to look at a more recent or up-to-date review to see if they've fixed any of those software or firmware issues. But with all that said, I think it's a great printer. Overall, I'd probably recommend going with the K1 or the P1P over it, just because the build quality on those two machines is so much more premium. So, thanks for watching, and I'll see you in the next episode.